Hey, how are we? It's Mr. Estrada here, and our learning target for this video says I can prove that two triangles are similar by the angle-angle theorem. So this is the theorem we're going to be working off of in this video, and it's called the angle-angle theorem, and we use it to prove similarity. So what the theorem says is to show two triangles are similar, it is sufficient to show that the two angles of one triangle are congruent to two angles of the other triangle. So for our example here, if we know that angle A is congruent to angle D, and we know that angle B is congruent to angle E, then we can conclude that the two triangles are in fact similar. And if you think about it, it actually makes sense, because if this angle is congruent to this angle and this angle is congruent to this angle, then we know that this angle here will be congruent to this angle here. And if all three of the corresponding angles are congruent, then that means the triangles are similar. So that's why the theorem makes sense. So again, to summarize this, if you want to show two triangles are similar, it is sufficient to show that two angles of one triangle are congruent to two angles of the other triangle. So let's apply this theorem to three examples, and then we are finished. It says, are the triangles below similar? Justify your response using the angle-angle theorem. So we could say these two triangles are similar. We could say triangle ABC is similar to triangle XYZ, and here's why we could say that. By the angle-angle theorem, we know that angle B is congruent to angle Y, since they're both right angles, and we know that this is actually supposed to say angle A congruent to angle X, so let me go ahead and change that. Angle A congruent to angle X. So angle A is congruent to angle X since they both measure 30 degrees. So we could say these two triangles are similar by angle-angle, and you see what I did there. I said angle B is congruent to angle Y, and I gave a reason for it. So it's not enough to say that the angles are congruent. You have to give a reason for it. And then I went ahead and I said angle A is congruent to angle X, and I gave a reason for that. So you always want to give a reason to back up your statement. That says reason there. Example 2. Given AB is parallel to YX, prove that triangle ABZ is similar to triangle XYZ. So we know that AB is parallel to YX. That's all we're told. And with that information, we are being asked to prove that these two triangles are similar. And I'm going to do a two-column proof for this. So I'm going to make two columns. One column will say statement, the other one will say reason. So as opposed to doing a paragraph proof, like I did in the first example, this is a two-column proof. And your statements will go on the left side. Your reasons to back up those statements go on the right side. So for my first statement, I'm going to say angle AZB is congruent to angle YZX because they are vertical angles. So since I know that these are vertical angles, I could say that they are congruent to each other. So this angle is congruent to this angle. Now, to prove my other set of angles congruent, I'm going to use this information they gave me here. So using that information, I can say that angle B is congruent to angle Y. So I could say this angle is congruent to this angle. And here's why I could say that. Since AB is parallel to YX, these are alternate interior angles. So see, now I'm taking it back to last semester where we talked about alternate interior angles. So lines are parallel lines for alternate interior angles, so then I know angle B is congruent to angle Y. As a side note, you could have also said angle A is congruent to angle X for the same reason. So with this information here, I could now say that the triangles are similar because of the angle-angle theorem. And I'm finished here. Example 3. Given EB is parallel to DC, so you always want to label the picture with your given information. Prove that triangle ABE is similar to triangle ACD. And I'm going to do a 2-column for this one, just to get you used to the format. Statements go on the left side and your reasons go on the right side. And I'm going to begin by pointing out something that might not be so obvious. You need to understand that these are overlapping triangles. So you have triangle ACD, which is the whole thing, and then you have triangle ABE, which is inside that triangle. And let me go ahead and highlight that. So you got triangle ABE, which is inside it, and then you got the whole thing. So let me do this. Let me actually go ahead and split them up, just so it could help us visualize this. I'll be right back. All right, so I'm going to take that one, and that is triangle ABE. And then you got the big triangle. So here's the big triangle. I guess I could put it here. Have some room there. And for the big triangle, this will be A, this will be C, and this will be D. So those are the two triangles separated. Now the reason why I did that is because it does help to visualize some of the things that I'm going to point out in my proof. To start off, I'm going to begin by saying that angle A is congruent to angle A. And this is why angle A is congruent to angle A. Angle A is shared by both of the triangles. Angle A is a part of the little triangle, and it's also part of the big triangle. So it's kind of obvious that those angles will be equal to each other. And there's a name we have for that. It's called the reflexive property. And you use that for when you have a shared angle or a shared side. In this case, it's a shared angle. So we got one of the angles out of the way. Now we got to prove that another angle is congruent to another angle. And I'm going to go ahead and say angle AEB is congruent to angle EDC. So here's what I'm saying. I'm saying this angle here, AEB, is congruent to angle EDC. Is that what I meant to say? Actually, what I meant to say was ADC. That's what I meant to say. ADC. So I'm saying this angle here, AEB, is congruent to angle ADC. And here is why I'm saying that. This angle here, AEB, and this angle here, ADC, are actually corresponding angles. So since these lines are parallel, let me help you visualize this. Right? These are parallel lines, line EB, and then you got the other line, DC, and then you got this line here that's acting like a transversal. These are corresponding angles. So I could say this angle is congruent to that one because they're corresponding. So my reason is, since EB is parallel to DC, these are corresponding angles. And then finally, I could say that the triangles are similar by the AA theorem. Okay, so just to summarize the video, this video was about using the angle-angle postulate to two triangles are similar, and I hope this helped. Look forward to working on this topic with you tomorrow. Take care.